Hey-oh.
Hey, 1.4 day. Whoop whoop. Okay, properties of real numbers.
2 minions coming at ya. FYI, this is a 2-day notes situation. So we're going to have 1.4 day 1, 1.4 day 2.
Don't worry. You have 2 sheets, people. It's all right.
All right, so we're going to talk about real number properties. You're going to be doing a lot of writing today, but it's going to be super exciting.
Get ready.
Oh, we're working it out. I'm going to be writing
Stretch.
too with my pen. All right, here we go. Okay, guys, the first thing we need to talk about is equivalent expressions. 2 algebraic expressions are equivalent if they have the same value.
Got it.
For all variables. So like okay, for example, x equals x.
Same.
That's an equivalent expression because if x is 4, 4 is equal to 4 all the time.
Yep. Yellow shirt equals yellow shirt.
What?
Same. Got it. Okay, first property we're talking about is the commutative property of addition and multiplication. Okay? It's on your sheet. We're going to talk about addition first, then multiplication. Commutative. C-O are the first letters of the word commutative. Okay? So, remember that commutative property changes the order. So if you make a C with your hand, the next letter that's easiest to make is an O. C to O. Changes order.
Oh, I'm doing it backwards.
Maybe I am.
I don't know. I always do YMCA the wrong way too.
Either one.
Okay, so changing the order of addition. So when we have an algebraic example, it's going to look like this.
So guys, write that down in the explanation.
A
Okay?
plus B equals B plus A. The A and the B,
Change order.
got it. Here's with numbers. 18 plus 54, you're going to get the same darn answer as 54 plus 18. They're equivalent.
Okay, I know those are bigger numbers, but if you did 1 plus 2, is that the same thing as 2 plus 1?
Oh, come on.
Yes.
They got it. They got it.
I know.
All right, multiplication, same song and dance, friends. You're going to change the order when multiplying. So that's going to look like this. A times B is equal to B times A. Or you could write AB equals BA.
Which we would prefer that. Remember, to get rid of any excess signs that you need.
Right.
Or don't need.
All right, so numbers-wise, we threw in a fraction. Actually, the book did that.
Yeah.
12 times half is the same thing as half times 12. You're going to get the same answer. All right, let's look at associative properties. Associative properties of addition and multiplication, I like to think of this as when you have grouping symbols, those are those parentheses or brackets or, what are they called? Braces. Okay, not these, the squiggles. When you have those and you have a set of numbers, it's the brackets change place. They change the numbers association. For example, if you look at A plus B in parentheses plus C, notice how the B was associating with A, but we changed the parentheses and now the B is associating with C. It's like changing your friends, okay? Or you can think of it as changing your team. You were on a team of 7th graders last year with all the same kids. You're probably on a totally different team, okay? It's kind of the same deal.
Yep.
All right. In numbers-wise, it can look like this. You're going to get the same answer if you add those. Hey, guys, again, if you need to pause because we're moving too quickly and you need to write it down,
Pause away.
pause away.
Okay?
All right.
Again, associative keeps the same. So it's A plus B plus C equals A plus B plus C.
The only thing that moves is the association of the letters within the parentheses.
Yep.
Multiplication looks similar. All we did was
the sign.
change the sign. Again, you could, well, we'll just leave it at that. And it would look the same with numbers. 7 times 9 times 10 is the same as 7 times 9 times 10. You're going to get the same answer.
So you should have the first 4 columns filled in right now. Next, we're moving on to identity properties. So the identity properties of addition and multiplication. Sum of any real number and 0 is the original number. So,
There. Sorry, my pen was going nuts.
so the identity property, the number goes in as one thing, it comes out the same thing. Okay? So it keeps its identity. It doesn't change. It don't change.
No, it doesn't. And that looks like that's a D.
There you go.
All
Got
right.
it.
So we're not changing the identity of the number. So when we're adding, what can I add to any number that's not going to change the identity or the value of that number? Big fat nothing.
0.
0. Here's an example for you if this doesn't make sense. Oh, well, they may
I don't
have
know
made,
why the book does that.
they made it really
Yeah.
difficult, but if
So like 1 plus 0 equals 1.
right, or 5 3/4 plus nothing still is 5 3/4.
Got it.
Same thing with multiplying. Although when you multiply, what do you multiply by to not change the identity of something? So,
So would it be 0?
well, no, because if I multiplied 5 by 0, I know I'm going to get 0. So what
Okay.
do I multiply 5 by so that it stays 5? Boom.
1. Got it.
Awesome. So that's not my phone.
No.
All right. So with numbers, 67 times 1 is 67. So we're multiplying or adding by something to not change the identity. All right. 0 property of multiplication. What did
So
you say?
what times, well, yeah, that was my example right before.
Right.
Okay. Anything times 0 is going to be 0. Okay. So 0 wins out when it's being multiplied.
Right. We learned that a long time ago, right?
Yep.
Yep. All right. So again, numbers wise, 18 times 0 is 0. You can put any example you want as long as it's something times 0 equals 0.
Yep.
All right. Multiplication property of -1. The product of -1 and a is -a. So basically what this means is if I have a number and I multiply it by -1, it's going to take that number and make it negative. So
Easy.
numbers wise,
Mhm.
-1 times 9 turns it into -9.
Now, what if I have -1 times -9? Would that still be a multiplication property of -1?
What was it again?
-1
Okay, let me write this down.
times -9.
Well, I'm still multiplying by -1, so really all it's going to do is make this opposite.
Correct.
So this would ultimately be 9. And I know you guys know that from 7th grade. Negative times a negative equals a positive.
So just know, guys, that still applies to this rule. Okay? You're still multiplying by a -1.
And you're just making the answer the opposite.
Got it?
All right, moving on. All right, now we're going to identify the property that's illustrated. What I want you to do is I want you to pause the video. I want you to answer A, B, and C, and we're going to come back and go over it in just a second. So pause the video now. Okay. We
job.
didn't pause.
Nope, we were here.
We were here the whole time. All right, so number 1A, excuse me. 31 times 0 equals 0. That's going to be
0 property of multiplication.
0 always wins. Anything
Yep.
times 0 is 0. Number B, I see that it's x plus 3 plus 6 equals x plus 3 plus 6. The numbers stayed in the same order,
Yep,
but
x36, x36.
the parentheses changed who they were associating together. So
Got it.
this, my friends, is associative property of addition.
Make sure you include of addition,
You
okay?
can't just write associative property.
Got it.
Okay. Now this one is 5x plus 0 equals 5x. 5x goes in. We add nothing to it. It comes out the same identity. Identity property of addition. Awesome. Let's try again. All right, writing equivalent expressions. We are going to write some expressions that are equivalent to each other by using our properties. Give me one moment and we will come right back to you. Far just walked in. Say hi, Far.
Hello. Learn your mathematics and algebra. It's very important.
Got it.
Well, I guess we don't even need
Said,
to pause.
said by the master himself.
All right, so in this one, we have to justify each step, and that's what we're going to do right now. So here, 4 times 8n. I want to change and group my like terms together, right?
Correct, because 8 and n are not like terms. So,
8 and 4 are.
correct.
So I'm going to do 4 times 8.
And we know that it's times 8 because parentheses stand as multiplication, as we remember.
So I have that.
Mhm.
And this step is associative property, right?
Yep. You change the grouping.
Associative of multiplication.
Mm-hmm.
You can abbreviate. Be careful on that abbreviation, though,
Yeah.
friends. All right, now I can simplify.
Mhm.
4 times 8 is 32?
Mm-hmm.
Yeah. 32 times n
32
is
n.
32n. And all that is just simplifying.
Yep. So you literally write out simplify.
Simplify. Cool. All right, next step. B, 3 plus 5b
Plus
plus 7. So we've got to change.
We need to group your like terms together.
So the first thing I need this 3 to move over here. I can't move the parentheses because that's not going to do anything. I'm going to move my 3 and change the order. Change order.
Wouldn't you move the 7 in the 5b?
No, because I can't do that outside of the parentheses.
True.
I have to change the order of the parentheses. That's good. That's a good
Yeah.
thought, though. So I'm going to do 5b plus 3. All I've done is change the order, plus 7. The property that allowed me to do this was
Commutative property.
commutative of addition.
Mm-hmm.
And now I'm going to move those parentheses.
Yep. Change the grouping.
So I'm going to have 5b
Plus
plus
parenthesis 3
3.
plus 7. So
Awesome.
you just shifted those parentheses over. But what allowed us to do that? The associative property
Of
addition.
Again, we are abbreviating. You can do the same. These are supposed to be arrows. I'm so sorry if they don't look like arrows.
Imagination.
Yeah.
Now you're getting ready to write on our heads too, so be careful.
Ooh, okay, so I'll just simplify down here.
Okay.
All right, so 5b stays right here, and I'm going to simplify inside my parentheses. 3 plus 7 is 10.
And then you write out what you did, which was simplify.
Simplify. Fantastic. Sorry if I'm
Bingo.
writing on our heads. All right, let's go. All right, what is the simplified form of each expression? Guys, we're going to throw you a loop here, okay?
Ooh.
8xy over 2x. When you see an x on top and an x on bottom, they cancel out. So I literally can cross out the two x's.
Yep, because x goes into x one time. So it's just like if you take 4 divided by 4, it's 1.
Yeah. So now I can simplify even further. 8 divided by 2, 4.
You're left with a y. Now, that 4 is on top because 8 was the numerator. So your answer, oh yeah, so 8 divided by 2.
There you go.
And y is left over.
Okay.
Good. Next, you guys are going to fill out the summary on your own. This one is a little more complex, but we have faith in you, okay? Is it possible to find a pair of numbers, m and n, for which m times the quantity n plus 1 equals nm plus 1? What can you conclude from this?
Let me give you a hint on how you're going to figure this out. Pick numbers for m and n. They have to be different. And try it out.
Okay, so stick away from 0, but definitely plug in numbers and see what works.
All right, see you on the flip side.